All right, we're about to get started here in a second. So grab a seat if you have not already. All right, hello everybody. My name is Nico Darrow, and I'm a senior TME for the Meraki MS switching team. And today I'm here to talk to you about some API hacks. So this is, the idea is, you deployed Meraki, you've got the environment. How can we start leveraging the platform as not just a provisioning or management tool, but a visibility tool? And as you start building out use cases, reporting, configurability, you want to be able to scale, especially for some of our larger MSPs that have thousands of customers. You want to be able to take that same programmability that you've learned and you've developed and scale that out over your infrastructure. So at the end of this, hopefully I'll be able to share it with you a little bit about AsyncIO ActionBatches, some tool sets that you can maybe add to your existing tool sets and be able to build up some of that scalability and power. So before we get started into the nitty-gritty Python code, I want to kind of explain or just revisit the Meraki platform and why it is what it is. And this is why we can do what I'm about to show you. But if you aren't aware, Meraki is Cisco's cloud platform of choice, right? We have a rich portfolio of hardware that can go and connect to dashboard. And this is where we start seeing the benefits of programmability, where we've got we have over 300 ecosystem partners that have been building in integrations and applications through our API. Now, this is only possible because the way we have a single cloud dashboard, right? A single source of truth for all device statuses, configurations. So when you write a tool set, you don't have to worry about the state of the device, right? Thinking about port configurations and AP and SSIDs, you want to make sure that when you write or you make a change, you don't have to worry about the devices online or do configuration mismatches. So this is why when we start talking about mass scale, it becomes very powerful with Meraki dashboard. Now, if you've attended some of my other sessions, or if you've heard the announcement, we announced the Dash M, right? This is the Catalyst 9300 Dash M born Meraki, right? Cloud powered, where we now have the same capabilities of Cisco Meraki, but with the same programmability. So the same scripting that you've been writing for Meraki switching works for Catalyst switching as well. And this allows a greater power. So even if you have monitor mode, so you don't have to have a full Dash M brand new switch. If you have existing 9300s out there, 9200s, 9500s, you have the ability to put them in monitor mode, which is a read-only state and dashboard. You're not changing anything, still have CLI, but you still have the power of the API to query that, see what's configured on the switch ports, see what the CDP neighbors are, and have that use cases to build onto it. And that's what we're going to demo here shortly. I've had sold a lot of use cases for customers where they wanted to do uplink management or reporting. And before we get into the results, I want to kind of explain to you a little bit about what a Python script normally looks like when we look at querying client lists or showing port tables. And small labs, where it's very easy, right? We have a pretty robust SDK available, right? You can go in and then, pretty simple Python script. This is an example, and I apologize for the contrast here, but, you've got your dashboard object really with a SDK where you create your instance, you point it to dashboard with your API key, and then you can say get organizations. And this is essentially the loop where you say for each organization, get the networks. And for each network, get network clients. And then for each client, you can say get client application usage, right? So this is just a simple loop iteration where you can see, I want to go for every organization that I'm a part of. I want to get all the networks that are available and the clients, and then get the applications that each one is doing. Now, if you look at it, I did a quick simple timer of each one. So you see here the get organizations 0.65 seconds, 0.47, 0.5. Now, the scale scale limitations that we publish from Meraki is 10 calls per second. Now, specifically, it's 10 calls per second per organization. And then specifically 10 calls per second per organization per source IP, right? So you're starting to see there's a little bit of depth there, but this is nowhere close to that, right? This is maybe one loop through here, you've got maybe 1 or 2 seconds. You're talking about one API call per second. And that's not scalable when you start talking about tens of thousands of devices. I have one customer that had like 147,000 network ports we had to query, and that could take several minutes, if not hours, depending on a lot of things. So how do we fix that? And this is something I'm happy to share with you. So before we go into learning something new, I want to kind of show you what AsyncIO is. So AsyncIO it's not a Meraki thing. It's a Python thing where it allows you to run tasks concurrently. So this is different than threading. If you are familiar with programming, you may take multiple tasks and you run them at the same time, right? That's essentially threading. Now, Python doesn't support threading, right? It's a basically single instance with a master lock, right? Where you can run one command at a time. So what AsyncIO allows you to do is to run those tasks concurrently, and AsyncIO manages which one goes first. So it's kind of like pseudo pthreads or cheating, but this is what we're going to use, and I'm going to show you how to use it properly, right? Because a lot of times people will implement this very linear, and you basically lose all the benefit of it, and you just add the complexity of, great, now I got to manage everything in an instance rather than just by command line. So traditionally, we would publish this SDK with AsyncIO and be like, well, for those that know it very well, good luck, right? So what I wanted to do is provide you guys with a library that you can download and basically just insert your code and benefit from the speed and capability of this solution. So so concurrent processes are better than parallel for a number of reasons, right? Because of usually resource constraints. So you don't have to worry about locks and stuff like that. So if you're writing to a switch and someone else writes at the same time, you don't have to worry about things blowing up. So there's some inherent benefits to leveraging Meraki dashboard. You don't have to worry about some of those things like error handling. So that's very simply what it is. And jumping into the next step, I want to explain to you like how we're going to use this. So if you think about a function call as a query, right, as getting a bucket of water, right, this is the traditional script where you would have a function call like get organizations, and then the purple thing here if you can read it, says return organization data. So it actually gives you back the data you've asked for. So it's very transactional. Give me the data, here's your data, right? And that's one essentially handshake, one bucket of water. Then you go through those iterations of next steps. So that's essentially going down the river, getting a bucket of water, coming back, doing it again, and doing it again. Now that's very linear. And if you start thinking about how you build scripts, and I don't know about you guys, but I've programmed on airplanes, I've in coffee shops, some dodgy wireless environments, definitely not Meraki wireless because it would work. And if you broke right here, everything here worked fine, everything past here did not. And you'd have to rerun the script. Now, if you're writing changes, this becomes problematic because now you're basically rerunning your script that may take an hour. And if you're 30 minutes in and then you break, you want to be able to say, well, how do I recover from that point? And then it becomes this a state problem. Now, the way we will do this is by queuing at the front and the end. So we want to move from just this like per function call basic solution to a like mass scale. And this is where AsyncIO comes into play, because it's not just a simple transaction basis. You're running the same function with slightly different formatting, but like you're in the same function and you get returned a future object. I like to equate this to like an IOU where you get networks, and I don't have the answer yet, but I'm going to give you a ticket, for that answer in the future. That's essentially what this future object is. You add some time, and eventually, when you query that future object, you have the actual data you want. Now, this time basis is random, right? So you don't know if it takes 1 second, 10 seconds, but the idea is you don't really care, because you want to do this in mass across all your networks. So get network, do that 1,000 times, stick it in one bucket, right? Kind of like, and then you give it add time, and then you can pull out the get network data for every network you have out there. Now the problem here is that you can only do it with like-minded functions or functions that return the same data. Otherwise, you're going to be picking, water out of the bucket, maybe a beer, and maybe like a sandwich. Like you want to be able to know what you're recovering from there without having to look into the data and reverse engineer it. So that immediately restricts what you can do out of it. And so if you want to take a look at the way I've structured the script, I like to call it trash packing. It's a skydiving term where you just jam it in, you just hope for the best, like your parachute, and you just hope it opens. In this case, what we want to do is create the same future object, but we want to return not just that future data, but a label that identifies what that data is, and of course the network ID or the org ID or whatever you're running that function against. So you have some context of what you're pulling out of the bucket. So now we can put in multiple functions and different features into this one bucket, add some logic to it, which I'll tell you in a second, and then as you pull it out, you have that data and you'll be able to sort it and organize it properly. Now, what's great is that you can also shuffle, and I like to shuffle stuff as it goes in, because you may be doing something sequentially, like get switch port neighbors or device port switch port device status, right, which would return CDP LLDP neighbors. It's an active call, which may take 1 second, could take 5 seconds. Now, if you take some big calls, you don't want to put all those big calls together because your progress will go hit those, some of the larger API calls, and then you've got 1,000 very small ones that will return faster at the end. If you shuffle them, you're now spreading the load out, but more importantly, it allows you for organization horizontal scale. Remember what I mentioned earlier, 10 calls per second per organization. Now, we've had customers that have 32 plus orgs. That's 320 potential API calls. Now, you could do some really cool logic and basically load balance and sort and stuff. Shuffling, I found, has worked very well. And the idea is that you don't want to have org 1, all your calls, then all org 2, and all org 3. You run them all, you shuffle them, and then you start pulling them out. Whatever finishes first comes out first, right? So I forgot to mention that. So as you shuffle, your sequence of what gets run is randomized, but as you pull it out, it's whatever finishes first. And the result is the ability to do this kind of mass scale querying at a time. Now, this does change the way that you may want to write a script, and I'm actually going to show you this live. I love doing live demos. It's very much entertaining. Let's see if I can find my screen. Is it up? All right, let me just jump out of presenter mode. So if you see here, I'm going to run this script. So this is called AsyncIO Benchy. So this is a repo that I will provide to you guys. And it allows you to give a quick demo against your environment on how this works. So what I'm going to do here is I'm going to run it. And what this script was originally programmed to do is to go through every organization you're a part of and download every API call you've ever run for the last 60 days. Now, this is a very intensive call because it's a lot of data. The more organizations you have, the more you're going to have to run, right? So I'm going to start this off. And when you start off running this script, it asks you, do you want to use AsyncIO, yes or no? Now, you can look at the code and you can see where I've put that in. Now, generally, you just want to use AsyncIO and not have to worry about it. But I want to show you the difference in performance between the two because it is considerable, right? To the point where you're like, oh, I need to do that. So this is going to run. And then what it's doing is that for every organization, I'm trying to be as optimized as possible. I want to say, get me, half a day worth of data. And it goes to the next org. So it's 3 organizations. It's running through, and it's going to be getting all the API calls that have been run against this organization since the beginning of time. Now, it's a little bit of inception because the API calls I'm running, I'm also returning. So it's constantly getting a bigger and bigger data set, which is fun. So while that runs, I'll jump back into the prezo. And essentially what happens is you get a much greater performance because you're leveraging 2 things: the horizontal scale across the organizations and shards, as well as the buffering that each of our shards have, which means that you can queue up to 100 commands before it limits you. And AsyncIO also provides you with the ability to tweak your session, which we'll get into in a second. So the speed test that I'm running is this API backup. So this is the AsyncIO Benchy script that I'll have a repo for. And you can see that a traditional script gets you about like 1.8 calls per second, far from the 10 calls per second you would normally see. Now, this is great if you have one individual that's running a script. if you have something that's running perpetually or on a cron job, or you just want to run a backup and someone else runs a script at the same time, you may run into a collision where they're consuming calls per second as well as you. His script breaks, your script breaks, and then this concern. So with this API backup, you can see non-AIO. The best I've been able to kind of tweak without async, you're getting about 6.7 calls a second. With AsyncIO enabled, I'm getting about 93. So that's well above the 10 calls per second that you're expecting. And this allows you to do things like buffering or querying the entire organization you have up front, because it's faster than doing it line by line. That way, you can also get all the information first before you start running logic. So instead of if you want to make a port configuration, say you want to go and add a VLAN to every AP port out there. Now you want to first query every switch port you have, look at the tag. If it's an AP port, then I want to add a VLAN to that if it doesn't exist. So that logic, instead of going port by port, you get all the ports across your entire infrastructure at one time, and then you basically commit that change. Now, you can see it's still running. Oh, well, take my word on it, it's still running. I'll drop it off when it's back. So, and I've also built some designs around this where customers want to take this data and actually get information out of it. And one of them is get switch error, right, which looks at uplinks on switches. So look at every switch I have across my organization, 147,000 in this one customer's case. Look at the uplinks, and if I see CRC errors on it, right, then run a report. So now I can prioritize which sites, which stores, which branches need a truck roll, or which sites we should upgrade the optics on. But you're leveraging the network as a sensor to figure out, what the problems are, right? And it tells you what we need to address. It's still running, by the way, so it's going to be a while. This is going to be a good one. So getting down to how do I use this? This is great. AsyncIO. I do not. I'm not going to learn it because I need it to work, right? And this is where I'm also providing you with this like starter script template. And of course, I'm not a professional programmer, but I like to do it on weekends. The starter script is a great way where we have this get all, right? Get all the information up front in the script. And sorry, this is how you would structure a script, or how to insert your code into this. So you get this initial where I'm going through every organization I have, getting all the switch ports, SSIDs, whatever you're trying to manipulate. This is where the logic happens. So this is going to return you basically a list, a dictionary of all the data you've requested at real time. And then you'll go through each of the port, do all the logic. This runs exceptionally fast because it's all in memory. You're not worried about connectivity to the internet. At this point, all the data you need to get is here. You run the logic here. You create whatever future commitment, whatever you want to commit, into an action batch. So action batch is it's also a library we have that allows you to take a command and run it in a batch, right? So action batches is part of our SDK. We do have a helper script that allows you just to pass it a bunch of db.batch. Whatever function call you have, put it in a list, you give it up to 100 per batch, and then it just runs. Now, what's great is that we're buffering all the gets up here, you're running your logic here, and then we pass what you want to write to the action batch helper. And then I like to pickle it first. And pickling means taking this memory object, serializing it, and putting it on disk. So you're basically making a save before you commit. That way, if there's a problem, you don't have to do all this again. Or you also have a record of what you've done. So at this point, once you pickle it, we haven't written anything yet. Then we pass it off to the helper, and then it just runs it. So these are port changes, SSID changes, any kind of puts or updates, right, go into this section here. So feel free to grab a screenshot of that. I will have this available to play with. So that being said, yeah, I'm going to let screenshot go. All right, cool. And then let me show you the result here. So here you go. This is this ran, right? We've got 21,384 records. It ran for about 270 seconds, which it's not terrible. It's actually pretty good. But let's rerun the same script with AsyncIO enabled. Now, this, of course, demo gods with us. Should be slightly faster than 270 seconds. It's 5.8. That's slightly better. I'm not good at math, but This is why I'm saying is that, okay, wait. Logically, you got to get your mind around like, oh, I want to be as efficient as possible. I only want to do 33 API calls. Yeah, but you can do 3,000 way faster, right? And that's the power of the dashboard. So the idea is get more data than you need up front so that you don't have to worry about waiting for making sure the data is available. Do the logic, write the commit, and then leverage it via AsyncIO, because it's not just a speed thing. There's other ways to optimize this as well, right? So let me jump back into the script. So this is essentially what you'll get with the starter script as well. So 2 scripts, the AIO Benchy, which is the benchmark tool. Starter script is like I use it before I start things, so I don't have to rewrite things from scratch. All I have to do is just uncheck what I want or don't want out of this section, write my logic here, pass it on to ActionBatches. I'm done writing the script in 5-6 minutes. So if you want to kind of get into the actual hacking of the API, right? This is where I love to show what's possible with it too, because it's more so than just a cool trick. This is the traditional object you create when you write a sequential script, right? Or a traditional script, right? You inherit the Meraki SDK. Here you create it, you point it to API, you logs yes or no, and then you run it. Now, there's nothing else really to this, right? If you make a mistake, you want to run it faster, slower, with errors, like it's limited. AsyncIO, slightly more complicated, but it has more commands which I can't read here. But there's like retry wait times. There you go. Yeah, maximum retries, maximum concurrent requests. So it's very tweakable and tunable. So maximum retry is about 100. So if you do have a collision or you do exceed your calls per second, it's going to send you a 429, like basically like, hey, hold off, you're calling it too fast. This SDK handles all the back off timing and waiting and retries for you. So you pass it, output log, yes. Concurrent requests, I'm only doing 10 per second. You can tweak that based on your needs. But the best thing is the back off time. Now, this allows you to do really cool things like QoS on scripting. So if I'm doing a configuration backup hourly, and it's running 30,000 API calls, I want to be able to run another script and not have it just completely trounce it, right? So with a much higher backoff time, like a 5 or 15 minutes, if you do hit an error, my configuration backup will wait 15 minutes. Meanwhile, my my more critical one is only going to back off 5 seconds, right? So that way you can have a pseudo QoS built into it, as well as all the retries, so you don't have to worry about it crashing. Now, it'll crash if you get it a big enough data set, but it is a lot more resilient traditionally than a single sequential instance. And, there's a lot of other tweaks you can do as well, right? So I mentioned shuffling. This is, I found this has been very helpful, right? Being able to shuffle it, that allows you to spread it across multiple orgs. The more orgs you have, the faster it goes, right? And it becomes a little bit more scalable. And yeah, and then of course there are definitely keep watching our SDK releases, because as we release API, we are adding a lot of org-wide summaries where you don't have to do this. You don't have, if you want to do a device-wide inventory status report, before you'd have to go to every network, query the devices, see what they were up or down, and that required multiple calls. We are writing org-wide summaries so that it's a org-wide single API call to return that result. So if you're able to leverage that as well as optimize it with this, you should have a significant benefit to the tool. And then this is the code. If you want to grab a screenshot of this, I'll leave it up for a minute, and then I want to show you the starter script and how to get started with that. So GitHub/Wi-Fi Guru 10. I've got the AIO Benchy as this first link up here. This is the tool that I use to demo it. Feel free to run it at home to prove that it works, right? It will query, it will ask you at the beginning, yes or no, if you want to run it via async or normal. It'll automatically know the organizations you're a part of if you put in your API. Starter script is what I'm about to show you here. Batch helper, this was written by our director of MS right now, but this helps you take those commits you want to do, right? So kind of like the benefits of the AsyncIO on the gets. you want to have the same benefits on the puts, right? So instead of going sequentially right, you're passing it a batch of commits. And this is important if you're doing like switch port configuration, or if you're doing something at scale. You don't really want to wait for that port to be written before you go to the next one. You can write them all, let them commit at their own pace, and then later on, take a look at it. So this helps speed that up, and you'll see that you can get significantly more capability that way as well. And this is a use case that I had, the get switch error, where I want to look at the uplink ports on all my access switches in the environment and find those bad optics, the bad cables, right? And that's one use case example of how you can leverage this to, use the network as a sensor and scale. And of course, our automation scripts that we have from our public repo from Meraki, we have a lot of configurations and scripts that have been written and added to this repo. So if you want to look for an existing use case, there's a lot in there as well. So just a quick example of, how this. Right, so this may not be, let me see if I can just zoom this in a little bit. Zoom it out. About 4 minutes, so this should be perfect. So take a look at the the starter script, right? So this is essentially what AsyncIO is, right? You can't run AsyncIO as an object and then pass it around like a traditional dashboard object. When you run AsyncIO, you've got to run all your commands in that little bucket. That's kind of why the trash packing works. If you do it one command line at a time, you're not going to get any benefit of scale. So here you create the async object, and then this is the bulk of the data. And if you can see here, it's just going to go through orgs. I'm going to start building that bucket of data. If you scroll down, you'll see this area here, and this is going to be get task, get networks, get devices, oh, that was it's probably my YubiKey. That's the that's not even the word. Get device statuses, get devices inventory, licenses, templates. So you basically just uncheck what data you want. You can get it all. If you just want to, take a look at inventory and uplink statuses, it's a lot faster. And then you can see here, this is where it'll go through and basically just wait for the tasks to come back. And then if it's a device statuses. So on the egress from that bucket, it sorts it into a dictionary. And I will run that demo for you here. So this is essentially get starter script, right? So this is a very simple, it has the logic, or it has the flow, so that it's going to go through all the organizations I had, get all the inventory, the devices, templates, configuration, licenses, all that, much at the same speed that we showed you the API backup. But this allows you to now just look at the data. So I want to actually manipulate it and see what's out there. As you can see here, it's going through a few things, and then of course it's going to crash. But it passes you back a bunch of objects, right? So it's a dictionary of network objects, and then you just use your key for the organization ID. So you can say, for device in device for this org, do this action. And I'll show you this, basically show a device here in a second. All right, so the demo gods are not good on that one. But at the end, you'll have a result. So let me go down to that. So this is essentially how you run that command, where, with Python, you can run your function, and then you can have it populate multiple variables. And this is going to be like the network clients. So network clients in a dictionary where it'll, identify it by org ID first, then networks, and so on. And give this a try. And then this is using IPython, which is an interactive Python. So you can actually go in and say, type it as you play with it. And it'll tell you which one of the toys are here. So these are the actual dictionaries that get passed back. That being said, definitely thank you for your time. And if there are any questions, feel free to reach out to me. If you want to have a specific use case, or if you're interested in learning more and the scripts aren't sufficient enough, I'm more than willing to help and help you get started. So anyway, thank you for you guys' time.